Introduction to IAM. Let's start with the basics and explore what IAM is. To do this, let's look at a hypothetical and then relate back to IAM. Say you're a freshly employed office worker going to your new office. When you reach, there's a guard at the building door who won't let you pass without seeing your company ID card. Once he verifies who you are, he lets you into the building. You work in the HR department, and your corporate ID card also serves as a key card that you can swipe against a keycard reader to let you into that office space. At this point, you think, gee, I wonder what the records in finance departments look like. You swipe your ID to find that it doesn't permit you to go into those departments. That's what is known as access control, making sure that you can't access things you're not supposed to. So where does IAM come into all of this? Well, in our hypothetical, the guard at the office doors was the IAM, making sure that you had the right credentials to enter the office. And IAM was also what defined how much access you had within the office. Put simply, IAM is the key to the door that unlocks your AWS resources, as well as the security cameras that survey who goes in or who comes out. Given the hypothetical we've just discussed, you should now understand that where you're going to encounter IAM within AWS is going to be at the very beginning. It will be the first service that the user will interact with before any other AWS services. There are a few core components of IAM that we need to acquaint ourselves with earlier on to understand how it works down the line. Let's look at them one by one. Users. These are objects within IAM, identifying the different users. Groups. These are objects that contain multiple users. Roles. These are objects that different identities can adopt to assume a new set of permissions. Policy permissions. These are JSON policies that define what resources can and cannot be accessed. And finally, access control mechanisms. These are mechanisms that govern how a resource is accessed. As an AWS account owner, it is your responsibility to understand how to implement IAM upon your resources. IAM provides you with all the components to maintain the management of access. It falls upon the owner of the AWS account to ensure that they are implemented properly. The scope of responsibility can be defined as the level of security to be imposed upon the resources. Do you need to restrict access to certain resources for certain users? Do you need the password to be refreshed regularly? Do you want to disable access from certain regions? These are all questions and factors that you need to consider when setting up your IAM. Just as it is important to understand how to implement IAM properly, it is also vital to understand the dangers and hazards of setting up poorly. Without having IAM set up properly, there would be little to no means of controlling who has access to what resource within your IAM, and passwords could very easily be guessed if they're not strong enough. Your AWS resources could be misused or, worse still, stolen if you do not set up your IAM properly. To find IAM in AWS is pretty simple. When you go to your AWS tabs, you're going to see that there's going to be one called Security, Identity, and Compliance. Under that tab, you're going to see the first resource should be IAM. Let's look at a brief summary of what we've done in this lecture. We now know what IAM is, what components IAM has, what IAM does, and why IAM is important. Congratulations! You've learned the basics of what IAM is. Now we can go ahead and teach you a few more advanced things about IAM. IAM Features. Here are some of the main features that you will find within IAM. We will be exploring each of these features and seeing what they can do for us within the scope of IAM. You can control and specify exactly what kind of access you want to allow to your AWS services and resources. This can be done by attaching policies that specify the access type, performable actions, and the resources that can be manipulated by those actions onto your IAM roles. You can also set conditions under which access is granted. For example, you can allow access through specific AWS services or organizations. IAM roles can be used to provide delegate access to users on your AWS account. Delegate access is an excellent means of providing a temporary access to users and workloads to perform required actions in your AWS account. IAM Access Analyzer is a great way of ensuring that you haven't given extra permissions to any role or user. It streamlines the process by checking for unused permissions and removing them, thereby refining the accessibility and obtaining a least privileged situation where nobody has more access than they need. With AWS organizations, you can use Service Control Policies, or SCPs as we call them, to establish permissions guardrails that all IAM users and roles in an organization's account adhere to. Whether you're just getting started with SCPs or have existing SCPs, you can use IAM's Access Advisor to help you restrict permissions across your AWS organization. Attribute-Based Access Control, or ABAC, is an authorization strategy that you can use to create fine-grained permissions based on user attributes, such as department, job role, and team name. Using attribute-based access control, you can reduce the number of distinct permissions that you need for creating fine-grained controls in your AWS account. How IAM works. When working in IAM, it's important to understand the terms that are going to be used within it, so that you know what's being talked about when it's being talked about. These terms are as follows: IAM resources, IAM identities, IAM entities, and principals. We'll be exploring these in a few moments. Let's start by discussing the principal. A principal is a person or an application that can make a request for an action or operation on an AWS resource. The way it does this is the principal is authenticated as the AWS account root user, or as an IAM entity to make requests to AWS. Previously, we spoke about how principals make requests for AWS resources. Let's take a look at what these requests are. When a principal tries to use the AWS Management Console, the AWS API, or the AWS CLI, that principal sends a request to AWS. The request includes the following information. The request will have actions or operations inside it that are required or wanted to be performed. It will further specify what resources it wants for those requests to be performed on. It will also have a mention of which principal is making this request. Further on, we will find that the environment data, which is the information about the IP address, user agent, and basically where the request generally came from, that information is also found within the request itself. And lastly, the information pertaining to the resource is also within the request. This is known as the resource data, which links to other resources that may be in play, such as a DynamoDB table or a tag on an Amazon EC2 instance, things like that. By this point, we know that principals make requests. But what we don't know is that there is an authentication step between the principal and the request. Unless authenticated, a principal cannot make the request. Authentication is done in a very simple way on AWS. All the principal has to do is log in via their credentials, which are their email address and their password. Once they've been authenticated, they may make requests easily. Once a request has been pushed forward, it moves on to the authorization stage. This is where it is checked whether or not the request can be allowed or whether it has to be denied. By default, And this is the case for if you are not requesting via the root user, all requests are denied unless it meets the policy requirements to actually meet the resources with the request. The way authorization works is that they check via policies if the request should be granted. What we're looking for here is explicit allows. When the policy explicitly allows you to do what it is you've requested, you can go ahead and do it. One of the problems that you may experience with authorization is that you need complete authorization to perform actions in IAM. A single explicit deny will overrule any explicit allows that you have in your policies, and then all in all, your request is going to be denied. Once your request has been authenticated and authorized, AWS is going to approve the actions or operations that you want to perform in your request. Operations are defined by a service and include things that you can do to a resource, such as viewing it, creating, editing, and deleting that resource. For example, IAM supports approximately 40 actions for a user resource. Some of these actions are what you see on the screen. You can create a user, you can delete a user, you can get the user, and you can update the users. But if you wanted to do other things, for example, like say you wanted to play with an EC2 service, you could even start the instance, stop the instance, and run the instance. So these are just a bunch of the actions that you can perform once you've made it past authorization and authentication. Once you've defined the actions that you want to be performed in your AWS, now comes the point for resources. Because if you want to do actions, of course you're going to want those actions to be done upon some resources. Now, let's look at what those resources are. Resources are objects that exist within a service. Like, for example, we say that we have an Amazon EC2 instance, or maybe an IAM user, or an S3 bucket, things like that. So the service defines a set of actions that can be performed on each resource. So say if you create a request to perform an unrelated action on a resource, that request is denied. And for example, if you request to delete an IAM role but provide an IAM group resource, the request fails. And that's how you can expect your requests to work on your resources.
Hello everyone, and welcome to this lesson where you will learn about IAM policies in AWS. A policy is an object in AWS that, when associated with an entity or resource, defines their permissions. Permissions in AWS are completely handled by objects called policy documents. Policy documents are JSON documents that can directly be attached to users, groups, or roles. You manage access in AWS by creating policies and attaching them to IAM identities like users, group of users or roles, or AWS resources. So when a policy document gets attached to any of the identities, then only that particular identity gets permissions to do stuff. It is worth mentioning here that authentication in AWS is done via IAM users, groups, and roles, whereas authorization is done by policies. We will discuss two important types of IAM policies that is mostly used when you perform activities in your AWS account. So the first one is the identity-based policy. Identity-based policies are attached to an IAM user, group, or role, and these policies let you specify what that identity can do. For example, you can attach the policy to the IAM user named John, stating that he is allowed to perform the Amazon EC2 run instance action. The policy could further state that John is allowed to get items from an Amazon DynamoDB table named sales record. Next one is the resource-based policy. Resource-based policies are attached to a resource. For example, you can attach resource-based policies to Amazon S3 buckets, Amazon SQS queues, VPC endpoints, and AWS Key Management Service encryption keys. With resource-based policies, you can specify who has access to the resource and what actions they can perform on it. So let's understand the difference between the two with the help of an example. Here we can see that there is an account with the ID as stated 1, 2, 3, 4 and so on. The administrator of the account attached identity-based policies to the John Smith, Carlos Salazar and Mary Major users. Some of the actions in these policies can be performed on specific resources. For example, the user John Smith can perform some actions on resource X. This is a resource-level permission in an identity-based policy. The administrator also added resource-based policies to resource X, resource Y, and resource Z. Resource-based policies allow you to specify who can access that resource. For example, the resource-based policy on resource X allows the John Smith and Mary Major users list and read access to the resource. For resource-based policies, John can perform list and read actions on resource X. He is granted this permission by the identity-based policy on his user and the resource-based policy on resource X. Carlos can perform list, read, and write actions on resource Y, but is denied access to resource Z. The identity-based policy on Carlos allows him to perform list and read actions on resource Y, and the resource Y resource-based policy also allows him write permissions. However, although his identity-based policy allows him access to resource Z, so the resource Z resource-based policy denies that access. An explicit deny overrides an allow, and his access to resource Z is denied. Mary can perform list, read, and write operations on resource X, resource Y, and resource Z. Her identity-based policy allows her more actions on more resources than the resource-based policies, but none of them deny access. Zhang has full access to resource Z. Zhang has no identity-based policies, but the resource Z resource-based policy allows him full access to the resource. Zhang can also perform list and read actions on resource Y. Identity-based policies and resource-based policies are both permission policies and evaluated together. For a request to which only permissions policies apply, AWS first checks all policies for a deny. If one exists, then the request is denied. Then AWS checks for each allow. If at least one policy statement allows the action in the request is allowed. It doesn't matter whether the allow is in the identity-based policy or the resource-based policy. When using the AWS portal, you will come across a lot of time as an admin to create and assign policies for your users or services in AWS account. It is therefore important to understand the JSON format for the policy document. So this policy document you see here is an identity-based policy. This policy allows the implied principle that can be a user, group, or role to list a single Amazon S3 bucket named as bucket 1. Listing a bucket means the entity have permissions to list all the contents of the storage bucket named as bucket 1. Here we have a policy document for resource-based policy. The policy allows members of a specific AWS account to perform any Amazon S3 actions in the bucket named bucket 1. It allows any action that can be performed on a bucket or the objects within it. So that's all for this lesson. With this, I hope you have got an understanding of what are policies and how and why are they used in AWS. Hi all, welcome to this lesson where you will learn about roles in IAM. Let's start this topic with an example. Let's suppose we have two departments in a software house, developer and data analyst. What are the roles of a developer? So they can query a database, create some functions. They can also store or retrieve data from the storage. On the other hand, we have data analyst who can do some data preparation work, perform data cleaning, and they also have a role to perform the visual analytics on the trends and inside of the data. So these are the roles that we have assumed for these two positions in the software house. In AWS, roles are represented by these hats that you see. How do you allow these roles to a particular user? That's the question of the day. In AWS, roles are temporary access given to a particular user or service to do a given task. When a trusted entity assumes a role, they can perform the actions performed by that role. For instance, you can use the AWS Lambda service to query a database in one of your databases within the AWS. Or you can assign a task of data cleaning task to one of your IAM users. When that role is taken away from the service or user, they can no longer perform that action that they were assigned. An IAM role can be assigned to an entity for a minimum of 1 hour to a maximum time period of 12 hours. An IAM role is an IAM identity that you can create in your account that has specific permissions. An IAM role is similar to an IAM user in that it is an AWS identity with permission policies that remind what the identity can and cannot do in AWS. However, instead of being uniquely associated with one person, a role is intended to be assumable by anyone who needs it. Also, a role does not have standard long-term credentials such as password or access keys associated with it. Instead, when you assume a role, it provides you with temporary security credentials for your role session. You might be wondering when can you use the IAM roles? You use IAM roles when you want to grant access to an IAM user to use AWS resources in your account. Cases where you want to grant access to an IAM user to use resources in another AWS account requires use of IAM roles. You might want to allow applications or services to use your AWS resources to automate the process. Or you want some federated users who can access your AWS account resources outside of the AWS. Let's discuss a use case. Suppose you have created a Linux instance on AWS. For that, you must have EC2 instance running. And obviously, you would require some storage to write data and read data from. So for that, you have S3, that is the storage service in AWS. Now, how can this EC2 instance access the S3 storage? So for this, there must be some access defined for this EC2 instance. Here, you need to create a role for EC2 instance that will have S3 policy attached to it. To be more specific, Amazon S3 Full Access is the policy which gives full access to the trusted entity to access S3 storage with all permissions. This will then allow this EC2 instance to access the S3 bucket and all of its contents. With this, I hope you have got an understanding of what are IAM roles and how they work. Let's move on to the practical hands-on session to create roles in your AWS account. We will also learn about these 5 types of trusted entity types that you can create roles for.
Tags in IAM. So what are IAM tags? Tags are custom attributes that we assign to AWS resources, generally to keep track of how they're going and so that we know what resources have been used when we look at the bill at the end of the day. Tags are split into 2 parts. So when you make a tag, you're going to notice that it has a key field and an optional value field. Optional means that you can just leave that value field empty. That doesn't matter. The key part is a bit more important, and we're going to be looking at that later on. Together, the key and the value make a key value pair. Okay, so now that we know what IAM tags are and what they're used for, the question could be asked, why do we even use IAM tags? If you're familiar with AWS and you've used their services before, you probably already knew that tags are what you see as billing components. So then what are IAM tags? Well, in addition to identifying, organizing, and tracking your IAM resources, you can use tags in IAM policies to help control who can view and interact with your resources. Take this example. Now, we have a user here who can access EC2. However, they cannot access S3. Furthermore, this user doesn't even know that RDS exists. They can't see it. And this is how you can use IAM tags to help control who can view and interact with your AWS resources. So now that we know what IAM tags are and why IAM tags are used, let's take a look at how IAM tags are used. Tags help us identify and organize our AWS resources. That's probably already established. Many AWS services support tagging, so you can assign the same tag to resources from different services to indicate that the resources are related. For example, you can assign the same tag to an IAM role that you assign to an Amazon S3 bucket. When we're naming tags, it's important to remember that there are certain rules and conventions surrounding how you can set the names for your tags. Now, it doesn't matter what you set in the value, but the key has to follow certain rules and regulations. The first rule is that of character requirements. Tag keys and values can include any combination of letters, numbers, spaces, and special character symbols. The second rule you need to keep in mind is that tags are case sensitive. Case sensitivity for tags differs depending on the type of IAM resource that is tagged. Tag key values for IAM users and roles are not case sensitive, but the case is preserved. Say, for example, you have this department tag. So now that you've tagged a user with the department equals to finance tag, and you add another tag now with a small d for department, and you say that this department tag holds the value HR. This is going to replace the first tag. The second tag is not going to be added. For other IAM resource types, tag key values are case sensitive. That means you can have separate cost center and cost center tag keys the way you see here. For example, say you've tagged a customer managed policy with the cost center tag and the value 1234. And then you add another cost center tag with a small c and you say that that's 5, 6, 7, and 8. The policy will have both cost center tag keys.